Remember when we talked about this amazing service that we have that can sometimes rescue your analysis? You have contamination in your file, or you want to gain the RNA-seq by mapping the reads to it. And we went in when we did the align function of going into Fastq Utilities, and then we clicked the align pipeline and then mapped it to a target genome. Well, now I'm going to show you what those jobs look like when you return the results. So I've got a good and a bad example here for you. Actually, both of them are pretty good. Go into Workspaces, BV-BRC Workshop, Fastq Utilities, and then I'm going to go into the alignment folder. And I have good alignment example and then one less good. But let's just click on this one and look at it. And so we click on this checkered flag here, which indicates that the job was successfully completed. And so you can see you've got BAM files, which we'll talk about in the next video, that you can see in the browser. The BAM files are the reads, and the bam.by file helps the computer figure out how to configure that in the browser. And then you have two sets of reads here: the aligned reads that map to the genome and the unmapped reads that didn't map to the genome. Imagine you're doing dual RNA-seq, right? You could use this to pull out both the bacterial and whatever the host was, pull those out separately. And one was the one that you were mapped to, and one was the one that didn't map. So you'll be able to look at those and grab those and see that in downstream services. The text file just gives you the information about the file that was there. So this is from a Borrelia burgdorferi species. And if we go back up to that, and then this is the one that I find so much fun to look at. So this is the report. It's an HTML report on how well the pipeline did. How many of those reads mapped? The pipeline did fine. Whether the reads mapped or not depends on the choices you made and how good the sequences are. So let's click the view icon. So it's showing it, and I don't know, I just think this thing is so darn cute. And it's showing the percent of the reads that mapped. I know there are some people on the BV-BRC project who think this bouncing dot is really dumb, but I like it. And the pink means really good mapping down to lesser quality mapping, and the gray are the ones that are unmapped. So you're able to see that there, what percentage of the reads map to that particular genome all the way down. And then there are more statistics down there if you want to look at it. I generally just pay attention to the dot. But I want to go back up to alignment. So follow me in the breadcrumb and look at this example. And we're digging in a little bit more here and align to this one, to Wigglesworthia. This was taken from a tsetse fly, and we mapped those reads to this Wigglesworthia, which is an endosymbiont of that. So I click on that and click on the view, and then look at what we have. And you would look at that and you would think, ew, that looks pretty terrible, because you have only 1% of the reads that are mapping to that genome. But actually, look at that. This is a really small organism, and that's a good number of reads. And what this is telling you is that most of those reads, they belong to the host organism. So I was able to pull them out of this, and actually I was able to get a pretty good genome out of this particular sample. So even though this is cute and you would look at it and think, oh, this was a terrible failure, it wasn't. It was actually pretty good, because even though it was a slight percentage of this really large file, enough reads were there that we were able to get a pretty good genome. And in the next video, you'll see how good that was, because we're going to look at those reads on the genome browser. So thanks for joining, and good luck with your research.